Welcome back. In this video we're going to be looking at some triple only content, which is a titration calculation, looking at quite a tricky neutralization reaction, and we're going to calculate the concentration in both moles per dm cubed and grams per dm cubed. So just as a little reminder before we start, the equations that we're going to need to use in this calculation, to start off with, we're going to be using the moles, which equals the concentration times by volume equation. And then when we come to do the grams per dm cubed, we're going to be using the mass equals moles times mR, relative formula mass equation. So those are the two calculations we're going to be using. Let's have a read through the question, and as we read through it, let's bug the question as usual to pick out the key information. So a titration was carried out between 25.0 centimeters cubed of 0.1 moles per dm cubed of calcium hydroxide. So let's just circle those two numbers, so 25 centimeters cubed, and the concentration 0.1 moles per dm cubed of calcium hydroxide, and it was reacted with 18.2 centimeters cubed, so let's circle that, of phosphoric acid. Okay, and remember, with titrations, we stop the titration just when all of the acid and alkali have been neutralized. So at that point, we've got the correct molar ratio of acid and alkali, which allows us to use the molar ratio in the equation. So what have we got to do? We've got to calculate, that's our command word, the concentration of phosphoric acid, so that's the one that we don't know the concentration, in moles per dm cubed and in grams per dm cubed. So that's why we're going to need to use the second calculation, second equation towards the end. Okay, and we've been given the relative atomic masses that we will need for this calculation. So let's make a start with this. The first step that I always recommend when doing titration calculations is getting out the way the conversion of the unit. So we've got two volumes here. We've got the volume of calcium hydroxide and we've got the volume of phosphoric acid. So let's get those into decimeters cubed to start off with, because after all, the unit for concentration is per dm cubed, per decimeter cubed. Okay, so I'm going to put calcium hydroxide, just put the formula down there. And remember, the conversion of centimeters cubed into decimeters cubed, we need to divide by 1,000. So it'll be 25 divided by 1,000, and that will give us 0.025 decimeters cubed. Then we need to do the same thing for the phosphoric acid. So let's put down the formula for phosphoric acid. And this time we do 18.2 divided by 1,000, and that will give us 0.0182 decimeters cubed. So we've got the conversions out the way. The next step is we need to work out the number of moles of one of our substances. Now, which one do we start off with? Well, there's only one chemical that we know both the concentration and the volume of, okay, and that is the calcium hydroxide, because it's 25 centimeters cubed and it's 0.1 moles per dm cubed. So we use our first equation over here, moles equals concentration times volume, but let's make sure we put down exactly what we're calculating to help us keep track. So moles of calcium hydroxide equals, so the concentration, which is 0.1, multiplied by 0.025, and you can use a calculator if you need to, but that one I'm able to do in my head. That gives us 0.002 0.025 moles. Okay. Now, once we know the moles of calcium hydroxide, we can use that to work out the moles of phosphoric acid. But we need to use the molar ratio. To find the molar ratio, we go back to our symbol equation. So you can see 2 lots of phosphoric acid react with 3 lots of calcium hydroxide. Okay? And with this one, we're going from the calcium hydroxide to the phosphoric acid because we've just worked out the moles of the calcium hydroxide. So we need to divide by 3 and then times by 2. All right. So the molar ratio is a 3 to 2 ratio. And so we can use that to work out the moles of the phosphoric acid. So we do 0.0025 divided by 3 and then times by 2. So I'll do that on my calculator. So 0.0025 divided by 3 times by 2. Oops, I'll just do that one again because I think I mispressed something on my calculator. Divided by 3 and times by 2. Okay, so that gives us 0.0016 recurring, 0.0016. I'll round that to 167 just to make it easier for the next calculation. Moles. And so the last step is we need to work out the concentration. And so if we go back to our equation that we wrote at the start, we can see, let's move this across slightly, in order to work out the concentration, to get the concentration by itself, we need to divide both sides by volume, divide both sides by volume. So the number of moles divided by the volume will give us the concentration. And we just need to make sure we're using the correct volume here. So the number of moles is 0.00167 divided by, well, what was the volume of phosphoric acid? Let's go back to the top of our page. The volume was this one here. So divided by 0.0182. So I'll do that in my calculator. Divided by 0.0182. Okay, and that gives us our answer there. And I'll round this to 2 significant figures. 0.091575, and in the answer line there, I'll round that to 2 significant figures, so 0.092. So sometimes in the question it will tell you how many significant figures to report it to. The final step though, because that's the answer in moles per dm cubed, it also wanted the answer in grams per dm cubed. So we've got space for another calculation down here. So that's where our second equation comes in, that you can see up at the top here. So mass equals moles times mR. You'll notice both of these units end in dm cubed, so it's always per dm cubed. So actually that sort of cancels out, and all we need to do is convert the number of moles into grams. And so to do that, at the top we do the moles multiplied by the mR, and that should give us the mass. So we need to work out the mR of phosphoric acid, and it's given us the atomic masses at the top. So we do 3 lots of hydrogen, so 3 times 1, plus 1 lot of phosphorus, which is 31, plus 4 lots of oxygen, which is 16. So again, we can plug that into our calculator. So 3 times 1 plus 31 plus 4 times 16. So that gives us 98 as the MR, as the relative formula mass. So then the mass will equal the number of moles, and we just use the number of moles from the concentration here because it's already in per dm cubed. So 0.092 multiplied by the MR, 98, which gives us, so I've already got 98 on my calculator, so multiply that by the number of moles, 0.092, press equals. So that gives us 9.016 grams per dm cubed. 0. And let's do that to 2 decimal places. And that's our final answer. So let's just have a little look to see where those 6 marks we think might come from. Okay. So I'm going to work backwards this time. So you'd get 1 mark for getting the correct grams per dm cubed. You would get 1 mark for calculating the correct relative formula mass of phosphoric acid. You would get 1 mark for doing the concentration calculation of the acid. You would get 1 mark for doing the correct ratio for the moles of calcium hydroxide to phosphoric acid. You would get 1 mark for doing the number of moles of calcium hydroxide. And you'll potentially get 1 mark for doing your unit conversions. Okay. Now, some mark schemes will mark this slightly differently. Sometimes you'll get marks for doing the specific workings. So you may have actually got 2 marks when doing the molar ratio because it's a little bit more complex molar ratio to deal with. Okay, but that's a model working and setting out very, very clearly on how to tackle quite a challenging titration question there. So I hope you found this video useful. Tune in for the final video, which is going to be looking at a calculation to do with gas volumes. Take care. See you later.